So the customer sent us a defected PCB board, and I'm going to show you guys what it actually looks like under the 130 kV X-ray. So now we're turning on the X-ray inspection machine. And you can see this is what it looks like under the X-ray. And we are just trying to find a defected area. And looks like we have found it, which is right here. And let's zoom it in and see. And this is a 5 micron void. And now we're trying to use the void function to get some defective results. And let's use the void tool here. And as you can see, we have found a void on this solder ball, which is about 5 micron. And now let's get the results. And you can see this is the results for total area void, and max void area, and the total void percentage of this void defected area on this PCB board, solder ball. So what you see here is just a black dot for the void, but it's actually a invisible killer for the high-speed signal. And what you can do to the machine can be broken down into 3 parts. The first one is going to stop the signal. So the result would be is going to cause the internet pin from 3 PS to 25 PS. The error code is gonna increase 1,000 times, which means your 5G module is going to turn into a Ethernet. And the second part is the heating is going to explode, which means that the life expectancy of your machine is going to shrink from 10 years to only 1.4 years. And the last result of this void going to cause your machine is that it's going to cause any hardware issue to your mechanics on your machine. And one of the famous defective result of this is head-in pillow, which means you can break the component by just using your hand, and the maintenance fee is going to increase 6 times. So to conclude in one sentence is that the void on this PCB board is a black hole of signal, heat discharge, and reliability. Thank you.